Hello guys, welcome back to Maths on African Motifs. We are still on our mathematics grade 10 revisions. This is Euclidean geometry from the exam papers that we have, past exam papers, so that we can be able to understand how these questions are given and how are you supposed to actually attempt these typical questions on the Euclidean geometry. So we are given question number 4. That is a BHSP, that is from B to H to S to P is a rhombus. In this case, that is the whose diagonals intersect at a point A. So diagonals, remember, that is from H to P, from B to S. So these diagonals, they do intersect at what? At point A. And we are given BA 8 centimeters, from B to A, 8 centimeters, from A to P, 6 centimeters, and also the line AC is drawn parallel to BP. We are given this line AC parallel to BP. These two lines, they are parallel to each other. All right, as we can see here. If we are to check, this is what you're given as in the diagram below. All right. Before you attempt the questions that follow, whatever that you're given to calculate the size of the angles and this and that, one, you are supposed to understand the properties of the shape that you are given here. You are given a rhombus, which is a quadrilateral, and we know that for the quadrilaterals that we have, except for a trapezium and a kite, except for those two, the rest talk about a rhombus, talk about a rectangle, talk about a square. They follow the properties of a parallelogram. So the first thing that we actually know that is that it has all the properties, it has, let's just say has the properties. Has the properties of a parallelogram. All right, this is what we know. It has the properties of what? Of a parallelogram. What is it? Having sides that are parallel, opposite sides, which are parallel, two pairs. So in actual sense, this side, HS, is supposed to be parallel to BP. So it means at the end, HS is parallel to AC, is also parallel to BP. Okay? The same thing, this side of BH is going to be parallel to PS, from P to S, or the whole of this line. Okay, this is from the parallel sides. The other thing that we know about the rhombus is that the diagonals, they bisect at right angles. These diagonals from H to P, right? Let me just write this. Diagonals bisect. To bisect means they divide each other, divide into two equal parts. But they do not just bisect, they bisect at right angles. All right. What does it mean? The diagonals, they bisect at right angles. The diagonal, this is the diagonal from H to P, that's your diagonal. From B to S, that's the diagonal. So these two diagonals, where they do meet at this point here, they bisect each other, meaning to say HP is going to be divided into two equal parts. Remember, to bisect is to divide into two equal parts. This side will be equal to that side. So it means this diagonal that we are seeing here is going to be divided into two equal parts like this. That means from H to A, it is equal from A to P. The same thing from A to B, this side here is going to be equal from A to S, because the point A is where they do intersect. So it means at the end, this point A is the midpoint. All right, why are we saying it is the midpoint? Remember, the midpoint is the center point, the point that we find in between 2 points. in between 2 points, whereby this is being divided into 2 equal parts. So that's exactly what the point A is representing. That's the midpoint. So there are so many properties, and like I said, they do not just bisect, but they do bisect at what? At right angles. At right angles means that at 90 degrees. So meaning to say, this point here at point A, here the angle A, there's a 90 degrees here, there's a 90 degrees here, there's a 90 degrees here, there's a 90, they do bisect at right angles. That is at what? At 90 degrees. These are the properties of a rhombus that you're supposed to know. And also talk about the sides. We know that the sides, they'll be equal. These sides from H to S, from S to P, from B to P, from B to H. And also these diagonals, they do bisect these angles that we are seeing here. They'll be divided into 2 equal parts. These angles, they'll be divided into 2 equal parts. And remember I said, this rhombus has the properties of a parallelogram, meaning to say the opposite angles, the angle H, the angle P, add up to one another. They're equal. The angle B and the angle S, they are also equal. These 2 angles, the whole of angle S and the whole of angle B, they are equal. All right, we shall talk about that. But what is important, just these basic parts that we have, the basic properties that I just indicated here, they are very, very important. Okay, let us see our questions. The first question is 4.1. Write down the size of the angle BAP. All right, BAP. Remember, this is the point A. Already we talked about this. So if you know the properties now of a rhombus, you can actually have this angle because we talked about this. The size of angle from B to point A to point P is 90 degrees. Remember I said the diagonals, they bisect each other at right angles, that is at 90 degrees. So meaning to say BAP is equal to what? Is equal to 90 degrees from the concept that the diagonals, they do bisect. This part that I indicated, diagonals bisect at what? At right angles, okay? So this question was just of you knowing the properties, okay? 4.2, calculate the length, the size of the length BP, all right? So we need to calculate the size of the length BP from B to P. By realizing that this triangle B to P to A like this, it's a right angle triangle because we have a 90 degrees that we have inside here. Given 2 sides from B to A and also A to P, we can be able to calculate BP, considering that it's a right angle triangle. So I just want to take this part from B to A to P. All right, I want you to see what is happening there. Just like this. I hope you're going to be able to see this. All right, so it's like this. This is what we have from the point B, right, to the point A, and from the point A to the point P, like this. All right, this is our triangle. So if you are to check here from the point B to A to P, this is the part that I just took here. B, A, P, like this. So considering this, we have a 90 degrees at A, which is a right angle here at point A. Remember the concept that we explained before, and also have the answer that we said is 90 degrees. And we are given that from B to A, it's 8 centimeters. We have this side, 8 centimeters, also 6 centimeters. Yes, we know that from the concept that I explained, that from B to A, it is equal from A to S. So it is the same that here we've got 8 centimeters. If this is 6, it is also that here we've got 6 centimeters. So we could have even calculated BH because we know that BH is equal to BP, it is equal to BPS, it is equal to HS. So you can calculate whatever that you want. It is the same triangle that you can see here. So by having it as a right angle triangle, we can apply our Pythagoras theorem, okay, so that we can be able to calculate this side. So this is 4.2. So calculate BP using our Pythagoras theorem, because you're given two sides on a right angle triangle. So it follows that, remember that a squared plus b squared is equal to c squared, whereby these are the shorter sides. This is the hypotenuse. So the shorter sides in this case, according to this is the longer side. So the shorter sides are 8 and 6. So we're going to square 8 squared plus 6 squared is equal to c. That is the hypotenuse, the longer side, the one that is opposite to what? 90 degrees. Remember your Pythagoras theorem, guys. So this is equal to BP squared, right? So you can find the value of this by just simplifying direct on your calculator. You can even write this b p squared is equal to this side, okay? Then you can just simplify this side so that you do not confuse yourself. But this is just one and the same thing, okay? If I write a is equal to b, it is the same as b, it is equal to a. So if this is equal to this, it is the same as this is equal to this. This is what we just did, okay? So that we can just write our BP on them on one side. So like I said, you can just simplify this direct on your calculator, all right, which is going to give us a 100, or just do like this, that is 8 squared plus 6 squared like this. On your calculator, this is going to be a 100. So that is BP squared is equal to 100. Then find BP, you're going to introduce the square root because you have a square here. Whenever you have a square, to remove that square, you introduce the square root both sides. That is to remove the square, right? The square is simply removed by the square root, which is the opposite. So that is the square root of the answer that you have is going to be a 10. So that's BP is going to be equal to 10. All right, so this is in centimeters. You're supposed to maintain also the unit of measurement that you're given, that is before. So you're supposed to maintain that. So this is 10 centimeters. Pythagoras theorem is now applicable on this part because it's a right angle triangle. So you're having trigonometry in place of the Euclidean geometry. That is the mixing part of the topic, that one part from another topic must be applied or should be applied in another topic. That is what I always advise you guys to revise as much as you can, because it can be like that. You're applying what you know from one topic on another topic. There we have to apply the Pythagoras theorem. Why? Because this is a right angle triangle. So once it's a right angle triangle and we're given two sides, we can be able to use it. If it was calculating of the angles or something, we could have even used the trigonometrical ratios if it is possible. All right, so that is going to be 10 centimeters, which is our BP. All right, no problem. Let us see the other part, which is 4.3. Write down the length of AC. All right, they're just saying write down. It's like there's no calculation. Just write down the length of AC. All right, this is AC here. All right, let me just remove this part. We're done with this one. All right, what is happening on the point AC? This is question 4.3. From A to C, this one. All right. Remember, we said these sides, they are parallel. HS, AC, and BP, all these sides, they are parallel to each other. But they are not just parallel. If we consider the fact that is happening here, if we consider this condition that is happening, that A is the midpoint, this point here. So considering triangle B to the point S to the point P back to A to be like this BSP, this triangle. If this point A is the midpoint, a line is being drawn from midpoint parallel to another line like this, it definitely tells us that this point C is also a midpoint. C is also a midpoint of the triangle BSP. It's also a midpoint of the triangle BSP. And if it is a midpoint, therefore it means that we can apply the midpoint theorem because these two sides, they are parallel to each other. So what we have there is simply from the midpoint theorem. The moment that A is a midpoint and the line AC is parallel to BP, these two lines, they are parallel, and this point is the line is drawn from a midpoint. Therefore, it means AC, it's half of this side, which is BP, from our midpoint theorem. All right, so that was the condition there. So meaning to say our AC, the one that you're given here, is equal to half of, remember the midpoint theorem is going to be half of the side BP. So this is half of BP. So this one, we are simply applying the midpoint theorem. Let me just remove this here, done on this one. So let's just write here. So here it is the application of what? Of the midpoint theorem. All right, from the concept that we saw that a line here, what we know about this line AC is the point A, which is our midpoint. Remember, I said these diagonals, they do bisect each other at right angles. So the point A, we said the midpoint. That is the point that we know, not C. But for the fact that AC is parallel to BP now, it automatically makes this C to be a midpoint. So it's because of the line that is drawn from the midpoint, from a line here is drawn from the midpoint and parallel to the second side, to the other side, this one. Once they are parallel, then that is why we are considering what? Our midpoint concept. So this is because of the line drawn, right? The line drawn from the midpoint. All right, let us just say from midpoint, not from the midpoint. Let's just say from midpoint parallel to the second line. All right, just write in short here. You can just write in short to the second side or the second line. All right, which is actually the opposite side. This side here is just the one that is, it is opposite to, okay? So considering this is what we are seeing, that AC from the midpoint parallel to BP, therefore AC is going to be half of BP from A to C, then from B to P. So if it is like that, we are going to consider this AC is equal to half of BP, which is 10 centimeters. So that is half of 10 centimeters is going to be 5. So that is half of 10. You can just use your calculator also, or just 10 divided by 5, guys. 10 divided by 2, guys, that's a 5, or just half of 1/2. That is 1/2 times what? Times a 10. This is going to give you a 5, and this is in centimeters. Like I said, you are supposed to maintain the units of measurements that you're given. So this is, that is 5 centimeters. Okay. Then let us consider the other part of the question, which is question 4.4. All right, 4.4, determine the area of the quadrilateral BHSP. We want the area of the quadrilateral BHSP, all right, which is the whole quadrilateral actually. Okay, no problem. Let's do this and see what we have. The whole quadrilateral that we are seeing here is a rhombus, like we explained before. This is a rhombus. And in order for us to determine the area, we've got two ways that we can actually do this to have the area. All right, let's consider the way that most of us understand. We can see that these triangles, they are simply congruent figures. This triangle, this triangle, this triangle, and this triangle. BAH, HASS, these, they're the same in terms of their presentation. So meaning to say, the area of this triangle, the area of this triangle, the area of this triangle, the area of this triangle are equal. They've got the same area. How many triangles are there? There are 4 of them, all right? So let us just consider this as our reference triangle because we have like everything here. So you have 1, 2, 3, 4. So considering these 4 equal triangles, it follows that I can simply calculate the area of one triangle, multiply it by 4 because they are equal. So at the end, we can simply say the area is going to be given as, so A, I'm just going to represent this A for area. It is going to be 4 times the area of one triangle because they are equal. They are equal. Everything is the same. So it's going to be 4 times area of one triangle. All right. 4 times the area of one triangle because they are the same. So that is going to be equal to 4 times, remember, area of a right angle triangle because we said there's a 90 degrees here. So it's a right angle triangle. So it is going to be half BH. Remember the area of a right angle triangle, that's half base times the perpendicular height. So that is simply what you're going to have. So the 4 is for the number of triangles that are the same. There are 4 triangles. The half BH is for the area of each triangle. The area of a triangle is half base times the perpendicular height. So this is going to be, we're going to multiply. This is for the area of each, the area of one triangle. That is going to be half times the base. Remember the base and the perpendicular height, they are on a condition that they make up the 90 degrees. So what we have, 2 sides which make up 90 degrees. So this is the side AP and the side AB. These 2 sides, they make up 90 degrees. So that is one of these is the base, the other one is the what? The height. So it does not matter. You can refer this as your base and this as your height. So you're going to multiply BP, BA, and AP, which is from B to A, which is 8, from A to P, which is 6. All right, so that is it. So I'm just going to calculate the area of one triangle, this one, so that we see what we're supposed to obtain from that area alone, from that area on its own. So that is half 1/2. Sorry, that's going to be 1/2 times 8 times 6. You're going to multiply these two, okay? 1/8 times 8, 1/2 times 8 times 6. This is going to give you a 24. So the 24 is for the area of one triangle. But remember, we said there are 4 triangles that we have. So that is why we have to multiply this by what? By 4. So this is going to give us 96 square centimeters. So that is the area of the given quadrilateral, which is the area of a rhombus. It was just a combination that we see from the normal area of a triangle that we are used to, because we know this area of a right angle triangle. So you can take advantage of that. So using that area times 4 of these right angles.